All right, hello everybody. Thanks for joining. We're going to give it just a few seconds, make sure that everybody has a chance to join. Okay, let's go ahead and get started. So thank you for joining the session today. My name is Adam Hicks. I'm a senior solutions architect with groundcover. And I want to talk to you today about going from SaaS chaos to bring your own cloud freedom. And especially, I want to overview what that means when it comes to LLM observability or AI observability. Now that we're living in the AI era, it presents some unique challenges. And I'd like to talk to you about how groundcover can help you manage those unique challenges. So without further ado, let's jump into it. So I wanted to start with a little bit of ground setting about the state of observability up to now. Some perspective for you. So legacy observability is what I might call it. It's easy for us to cast aspersions on the past as we move into the modern era. But to be honest, like when we think about this, what we've seen is that SaaS platforms have evolved from legacy monitoring into this modern observability. They were built for a different era of IT. While they certainly played their part in how observability has transformed through time, they're truly struggling to keep up with today's cloud native world. Modern applications have shifted. We see microservice architectures, we see AI agents developed, interoperating with each other, agent-agent communications, and our interactions with LLMs. We're also seeing mountains of data more from this complexity in these distributed architectures than we used to see. Terabytes of telemetry data, frequently overwhelming your traditional architectures, certainly overwhelming a lot of the on-prem capacity management of yore, but even the SaaS platforms, and it can create processing delays as well as some monumental costs. We've seen a shift into a per gigabyte pricing model that has become prohibitively expensive as data scales. So sensitive telemetry data crossing organizational boundary also raises some compliance issues and, of course, with that, regulatory challenges. So teams, unfortunately, have become faced with unpredictable costs, siloed product lines, and they have to make data budget trade-offs, rate limiting, forcing teams to make difficult trade-offs between visibility and budget, employing things like sampling. And while there couldn't be good cause for sampling, maintaining fidelity without having to overburden systems, it shouldn't have to be a choice. And we've seen a return from this to self-hosted open source software solutions. And while I'm a big fan of open source, self-hosting oftentimes leads to a lot of operational burden. So it sort of begs the question then, how do we do observability right? If we can talk about the problems, what is the solution? When we approached this here at groundcover, we realized that this is fundamentally a data problem. A lot of what I was just talking about on the I'll call it the problem slide before this one was really about managing massive volume, the cost for ingest, how you store it and optimize it, as well as secure it. So at the end of the day, the way we started thinking about this is that the problem with the SaaS model is that it fragments your stack. Logs end up living in one tool, traces in another, metrics in a third. And while we've certainly seen some attempts, or I should say some solutions being provided from other vendors to unify them into one interface, inevitably when you dig underneath the hood, you find out that these solutions too are actually themselves siloed. I'll use the old sources versus sink terminology. Your sources being your applications and your infrastructure, and the instrumentation to get that telemetry, the relevant telemetry out. The sink being the database that you can now go do analytics on top of all of these telemetry signals. These sinks are purpose built for a lot of the, I'll say, like the telemetry types that are being ingested. They end up being siloed. So while there are ways to unify through metadata inside of a pane of glass, they themselves are not unified. So what ends up happening then is that you either spend a lot of time up front unifying them, bringing institutional knowledge in terms of how they should be unified, whether it's at source or it's at analytics layer, or you handle it through silos, which means that every time something breaks, engineers waste hours switching dashboards, trying to correlate symptoms across tools that don't talk to each other. And then what ends up happening is that during incidents, rate limits kick in right when visibility matters most. And the kicker, every gigabyte costs you more. You want to send more in during an incident, you pay for it. Observability shouldn't be like this. It should make debugging easier, not feel like you end up having to constantly debug your own tools. So at groundcover, we rethought things, and we realized that we need to think about cloud native first. This means infrastructure as a service, platform as a service, application as a service, infrastructure as code. We also needed to think about bring your own cloud native. And we'll talk a little bit about what that is and means in a second, but it was really important for us that we could allow our customers to keep data inside of their own four walls. We also recognized that we needed to be truly cloud native in terms of being able to meet our customers where they were. They get accustomed to tools and architectures and services from their cloud provider, so we needed to be able to work with those. We thought we could change the pricing model as well, since ingestion is now not a concern of ours. We can come up with a different pricing model. We now have predictable pricing based on what you monitor, what systems or hosts you are actually employing to do observability on. And that frees us. Then we don't have to employ any limits on you in terms of what data you're keeping and storing, whether it's by types, shape, cardinality, or volume. And we wanted to make it really, really easy for you to deploy, whether it's getting started with us in your own cloud or getting started instrumenting. I talked a little bit about this before, but the burden of troubleshooting your own stack and having to bring institutional knowledge from your organization so that you can do correlation across signals. What if you didn't have to do that? It was easy to deploy instrumentation, agents, or sensors that were super performant. And of course, we wanted to make sure that we could still keep up with where you're at and where all of our customers are at, all the modern collection methods. So this could be open telemetry, or, and we'll talk about this as well, extended Berkeley packet filter, or eBPF, and then also help you do observability on truly modern types of telemetry signals, which could be things like LLM experiences, which are a little bit different, and we'll talk about that too. So let's talk about what this BYOC, I mentioned it, bring your own cloud, what it really means. What it means at the end of the day is that you get to keep your data inside of your VPC, inside of your four walls of your infrastructure. But it's fully managed by us. You get the operational ease of software as a service, but you get the privacy and control of on premises, even if in a hyperscaler. And in a hyperscaler, we get all of the capabilities that allow us to scale this like it's a SaaS native service for you. But you can put it anywhere. So we see customers deploying this in everything from large financial institutions with strict compliance to fast-moving startups in EKS. Same performance, same cost advantage, no matter what. It's very flat. And because we don't require you to sample at all, because it's not ingestion based anymore, you can actually afford to store whatever it is that you want to keep in terms of telemetry. And that's what makes modern debugging possible. You don't have to sample out. You can maintain the fidelity you need to troubleshoot your applications and your infrastructure and get what you mean very, very quickly. So yes, to answer questions that may be on the tips of your tongues, and we're going to do questions at the end, but this gets deployed into your environment. The next thing that we like to talk about too, and I mentioned this a couple slides back, deployment ease. So we deploy the backend for you. So there is no management of this, even though it's running in your environment that is an operational burden on you. But then also inside of your environment, what it is you want to monitor, we make it very, very easy. The front end is accessed from our cloud. That is a SaaS-like experience. It is a single pane of glass that handles authentication in our reverse proxy to do queries across backends that you may have deployed inside of your environment. But we also offer a completely free or on-premises model too. So it could be air-gapped, and it could be just inside of your own infrastructure if you want it that way. We do have free in Teams versions as well that can be managed by you inside of your own environment if desired. But the next thing I like to talk about is the simplicity of instrumentation. I think the world is rife with telemetry agents, but it's also rife now with, especially as we get into how do we get context across distributed cloud-native applications with code-level instrumentation, tracing libraries, and there's a lot of value in them. They allow us to get granular with data in our business logic in a customized way that you simply can't do any other way. But there's a huge maturity that you need to go through in order to get to that, to where you can actually do that and find value from that. And one of the reasons that we see teams hesitating to add observability as opposed to traditional monitoring is the pain of that instrumentation. Endless SDKs, agents and agent configurations, even if you're not touching code, but on the other side, maybe you are making code changes, which becomes more of a challenge internal to the organization. You've got competing priorities between observability and resiliency and feature velocity, and how do they feed each other? So with groundcover, you just install one thing once. We have an eBPF sensor, extended Berkeley packet filter. And when you go deploy this into Kubernetes clusters or Linux hosts, it starts streaming enriched telemetry instantly. And when I say enriched, I mean that we are contextualizing for you all the way at source. Again, I'll harken back to that term I used before. Institutional knowledge that you need to do correlation, unnecessary with us. We understand how the metrics from a system and an application correlate to a trace that's been generated by a request, as well as a log output. So it hooks into the kernel layer, if you're unfamiliar with extended Berkeley packet filter, meaning that it actually sees every single request, every trace, every event, and you didn't have to touch application code. We don't do any injection. It is passive probing of the kernel entirely. So in practice, this means full visibility from day one, every microsystem, and now every call. And of course, if you want to mature beyond that and enrich that, you certainly can. This means that we're pretty unique. We get a full stack experience, a single pane of glass that unifies infrastructure, application performance, real user monitoring, and now LLM observability. No add-ons, no enterprise tiers from us, no AI monitoring SKU. It's all built in. All we're going to be pricing on and all we're going to be thinking about is how many hosts you have decided to deploy our sensor to and monitor with. External data that you may send in, additional telemetry, logs, metrics, or traces from other systems come at no additional cost. So when we talk about 10x more data for a fraction of the cost, this is what enables it. One unified system instead of 5 disconnected ones. But let's shift gears and talk about AI. That's really what we're here for. So of course, the bring your own cloud is a really powerful component for us, but I want to talk about why that's so special in this era of AI. That's really what we're here for. LLM applications are fundamentally different from traditional software. And we may say, oh, they follow distributed architecture, 12-factor. At the end of the day, they do and they don't. They're different. Especially if we're doing true agent-to-agent, integration with MCP calls with our agents, bots, they shift. They're probabilistic, multi-step, and they're dynamic. You can't just log a single request and call it a day. It doesn't work like that anymore. Latency balloons across agent chains. We see that time and time again. Prompt drift and hallucinations silently degrade quality over and over again. We're all familiar with hallucinations, especially when we're seeking fact-based responses from LLMs. And we know that we need to employ like significant RAG and fine tuning in order to mitigate that. And of course, one of the biggest problems of all is that sensitive data flows through prompts every second. We can't always gatekeep what people are going to go put into an agentic system or a AI application. And oftentimes it's in ways that compliance teams can't even see. And there's unique architectures that have emerged to do this, whether it's, pre-filtering, pre-scrubbing, or otherwise. On the observability side, you really need to have specialized observability for this. You need to be able to see where in time token usage and risks are going. You need to see what trends, what directions they are. You need to be able to account for them. And there's a whole different set of, I'll say, data points that you need to be concerned with and you need to be able to manage. This is the blind spot that this shift in the AI universe is introduced and where groundcover steps in. So what is LLM observability? What is that and how does that differ? At the end of the day, I mean, it's like observability of anything. We're looking to understand what's going on. The shift is that now we have to employ a practice of monitoring and analyzing how these large language models behave in production. Just like you just observe an application, but with new dimensions. I mentioned this before, new data points. There's new dimensions, whether we think about them in terms of trace attributes, different metrics that we may be looking at, or different features and logs. So at groundcover, what we have done is we have configured a way to actually collect specific LLM telemetry like prompts, completions, model latency, and token usage. These are really important. This allows you to find patterns and for us to surface some of these, like which models perform best, which prompts degrade, and where costs or errors spike. One of the other hidden things that we haven't talked about as much has been that token usage and the expense of interacting with LLMs. Especially when we're using ones that are not our own. They're not deployed. These models aren't inside of our own agentic systems. These are public ones that we're consuming. Ostensibly, we have a contractual relationship with them, and there's an expense for every single interaction. So the goal at the end of the day isn't just visualization. And this is how groundcover thinks about maturity with observability in general. It's not just about being able to go look and say, oh, we see the system and we see the interoperability. It's the ability to ask questions and use those questions and derive insights from them that lead to continuous improvement. That is the next generation of observability. I like to think of this as a little bit more like a feedback loop. It is collect, analyze, optimize in its most simple form. But we want to democratize and flatten access to this observability data. We don't want to gatekeep any of this observability data behind things like esoteric query languages. We make it very simple for you to discover exactly what you need, what features are inside of your systems, so that you can iterate and incorporate what's going on, say, in production into development of your products. So that loop is also how AI applications become more reliable, just like any others, but also cost efficient and production ready at the end of the day. So we have actually taken the classic pillars of observability, metrics, logs, and traces, and events, and we've extended them for the AI era. So this is a ground cover view of the 4 pillars around LLM observability. So number 1, prompts and feedback. These are at the heart of LLM applications, and logging them lets you identify drift, template failure, and quality degradation at the end of the day. Number 2, tracing is still an important signal. So we want to follow every step from prompt assembly to retrieval to output parsing, so you can find out exactly where latency or errors are appearing. Third, latency and usage. Really important, especially the usage metric. LLMs are expensive and they're slow. Tracking token usage as well as model versions and response time gives you direct cost control as well as valuable feedback for improvement and brokering. Final, retrieval analysis. For things like RAG, retrieval augmented generation, we want to be able to measure speed, cost, and soon relevance, which is, we think, the next frontier of AI observability. So we want to give you the ability to monitor every single LLM interaction. Now, go back to what I was talking about with bring your own cloud and some of this, the freedom that it offers. You don't have to sample. You can keep everything. It's inside of your own infrastructure. We're not charging you an ingestion cost whatsoever. So now you can bring every single one back and use that analytically to answer questions and improve your product lifecycle with. We capture every single LLM request and response. We capture the full payload. We capture all the token counts. We capture latency and even error patterns. And we do it with our eBPF sensor automatically. There's no proxy, no SDK, no wrapping your code. It all happens transparently at the kernel level. So this means that you can debug a failing LLM output with the same depth that you debug a 500 error, full context, full fidelity, and zero friction. Once you have this visibility, then you immediately gain control over one of the hardest parts of AI operations, which is cost. I mentioned this before, but this comes up time and time again. Token usage, what we have seen from LLM interaction is that it varies wildly across services, routes, even model versions. When you can actually see that data, you can optimize intelligently. So maybe you don't need GPT-4 or Sonnet for a classification task. I laugh a little bit to the days when machine learning was still considered AI, but it's certainly true. We see people employing AI and LLMs to do tasks that could easily be served by statistical methods instead of actually using large language models. So on top of that, we help teams monitor things like latency trends, error patterns, and model performance, which is vitally important. So when engineers can correlate performance, what we have seen, as well as when they can understand the spend directly, they make better design decisions. So when we go back to that mention that I made of high maturity democratizing access to data, this is where that comes in. We want to employ the capability inside of all aspects of our organization, not just operational, not just the response to what went wrong, but the response. We want people to be thinking more in terms of experimentation. How does this change affect these different signals? And what we've seen is that when developers can make insightful decisions about how they're employing this, then they can do things like reduce AI bills. We've actually seen it as high as 30% or more, and coming from the lens of performance rather than cost. So truly impressive indeed. So the magic moment for most teams is when they open a single LLM trace inside of groundcover. And I'll show you this in a live demo in a second. I have some screenshots here in this slide, but it really does come together because you get to see the entire journey. Which model was called, what retrieval happened, how long the tool took, the tool call took, and of course, where a misconfiguration may have occurred. In this example, a model mismatch error, GP2 too large does not exist, was immediately traceable to a specific service. No guesswork, no logs, no digging through them, no SDK stack trace. So this is how debugging AI becomes as easy as debugging a web request. The other thing I want to talk about is security. Because I think this is a really important area for a lot of organizations, and what has prevented so many from really getting into this. So many customers that we call upon and we talk to say, are you developing yet? And they say, no, it's on a roadmap. We want to, we have budget for it. We have not because of security and compliance, because we have concerns. One of the chief drivers for this is that they don't have any way of seeing the data. But also because they're worried about where spillover of this data may go. Even if they could observe it, does that then open additional risk? So for us, what we've seen is, to put it bluntly, is that it's a non-negotiable for our customers and for the world. And we believe that as well. So with us, every LLM prompt we understand could contain sensitive data, customer information, PII, or even intellectual property. And the last thing that you need is a vendor copying that data into their infrastructure. So with Bring Your Own Cloud, all that telemetry stays within your VPC, within your infrastructure environment. None of it is ever copied to our infrastructure or externally to us. That's how you get observability and compliance in the same sentence. Contrast this with, maybe an SDK-based tool that proxies your LLM traffic or ships the full payload to their SaaS platform. Bring Your Own Cloud means you get observability without creating new security vulnerabilities. And what we say is that the architecture difference isn't subtle. Honestly, it's everything. Where others require SDKs, we're able to use eBPF. Where they ship your data to their cloud, we stay inside of yours. We don't gate features or throttle visibility. You get 100% capture, flat pricing, and a single platform that handles infra, apps, and AI all together. So this really isn't about feature parity. It's a structural advantage, and it's why we can say with confidence that no one else can deliver this level of visibility without trade-offs. When something goes wrong in an LLM workflow, latency spikes or errors spike. What's the cause? Is it the model provider, a database bottleneck, or network congestion? With siloed tools, you're guessing. With groundcover, you see it instantly. We correlate LLM metrics with infrastructure and application data automatically. This means faster mean time to resolution, clear ownership, no finger pointing between ML, DevOps, or your platform teams. At the end of the day, reasons teams adopt groundcover isn't just performance, it's truly peace of mind. They get complete visibility, deploy in minutes, and never have to worry about hidden quotas or rising bills. So as workloads grow, especially AI, they know exactly what's happening, where it's going, and how much it's costing. And now I'd like to shift gears a little bit, and I'd like to drop into groundcover and show you a demonstration of the product directly so you can understand how LLM observability is functioning in the real world. Okay. So what I've gone ahead and done is I've pulled up my groundcover demonstration environment. And if you're new to groundcover, a few things that I'll explain to you. This is I'll call it like the home page. It is the standard default login page for most individuals when they're coming into groundcover. They get a view of workloads, and of course they have a view of any clusters that are wired up and any environments that may be tagged to those. We talked a little bit about that eBPF sensor. Let me go into this. I'll pick on a single cluster as an example. Let's take production. And in namespaces, we have a groundcover namespace. Now, there's obviously more than one thing running. Our sensor is the most important. This is our eBPF intellectual property that we have. These other elements are supporting. A few of them are optional. A few of them come out of the box, but I call them the supporting cast, or if you will, the supporting band, the lead singer. Some of these, like Victoria Metrics Agent, are allowing us to do things like custom metrics scraping inside of a Kubernetes cluster. Kate's Watcher is giving us insight into the Kubernetes topology. Vector and the metrics ingester are helping us with pipelines to bring data back in. This is not the most important feature here, but it is good things to understand just architecturally, which all together in concert, using the band analogy again, they work together to do that contextualization and enrichment of data all the way at source, all the way back to sync, and give us the ability to build analytical heuristics easily and quickly that are meaningful for you to go derive context. Now there's a lot of other really interesting rich telemetry you see out of the box here too. Things like request errors and latency across these workloads. And if I go into any one of these workloads, let's just pick one like shop service as an example, you get other rich telemetry too, whether it's a timeline that can include changes, pod status, warning events, and crashes, if there are live issues, as well as resources, pod, node, noisy neighbors. We also do API discovery for services using eBPF. Then we can build maps, contextual views of how these are connected. And if there are any issues, say shop service communicating with order service, how they may be affecting upstream. In this case, this is actually being affected by a downstream issue burning on order service. We also give you network telemetry, throughput, workload partners, cross availability zones, and connections, and more. The thing that I will say about all of these views is that a savvy observability user may look at this and say, these are awesome dashboards. And that's exactly right. That's what they are. These are, as I put this before, analytical heuristics on top of this observability data that we give you out of the box because we know that these are very relevant. But where we can really take things is allowing you to go explore this data yourself. And this is everything from APIs, logs, traces, events, or in our data explorer, even metrics. I'm going to start with traces. Our trace area right now is a query interface where you can come drop in key value based filtering to do search across relevant spans or traces and trace data. Oh, I actually have one here. Since we're talking about AI, and that's such a focus for our times, let's zero in on span type Anthropic and see what we can see. So I found I do have a service, at least one, that we see multiple spans coming in from, and I can zoom in and out on time. I can also expand this to include searches across other clusters, but eBPF very nicely, as you can see from the facets that are respecting my filter on the left, discovers the protocol. As many trace libraries would, ours does this out of the box. And that includes, a AI protocol, in this case, Anthropic. Where this really comes together is when I click into shop service. Now there's some interesting detail. This is a very beautiful view, but I want to slide over here. Oop, I apologize. I want to slide over here and zoom in just on this aspect of things. So this is, and I'm going to use this term. I'm going to overuse it. Hopefully you get tired by the end of this presentation, but this is beautiful context for us, and this is an out-of-the-box experience. What you have captured here is the Anthropic request details. So this is, again, another overused term, a built-in heuristic that we have developed for you, where we can understand what the request model was, what the response model was, input, output, and total tokens used for this interaction. And then also, most importantly, is the chat experience itself. We also can give you the full request payload, also give you visibility into the headers used for the request, and the response. What's really important to understand here is that when we think about how these respond, they are structured. And in this structure, it gives us the ability to identify things like PII. With ground cover, you certainly have a field here, is PII. And if we say, is PII true? We'll find out that yes, there are a number of services that we've detected that have PII, not necessarily interacting with AI. So juxtapose that to what we saw before with the Anthropic one. This one's a little bit more of a simple span view. But what we do see inside of this is that in our response, we have a user ID. So this could be considered PII as well as the email and or name. We give you mechanisms to obfuscate that data. We can do this at ingestion. We can do this at the sensor layer as well. And the sensor ecosystem is part of that orchestra. So it's very, very powerful, giving you all the security and controls that you need. And this extends into the payloads that may be observed interacting with an LLM. So I want to go back to LLMs again for a second, because while we give you this beautiful view inside of traces, what's really important is that we have all of the raw fundamental data at your fingertips as well. This comes together when we want to go build dashboards or just do data exploration in general. Our dashboards, since they're built on top of our Query Explorer for query exploration, let's jump into an LLM observability purpose-built dashboard that we've created. In this case, we have managed to build lots of different visualizations and charts that I think are really important when it comes to LLMs and AI. Something like total LLM calls with inside of a specific time period. Now, our dashboards also give you the ability to go build variables, so you can use those, and that'll drive the widgets as well, so you can focus on LLM as observability as a whole across all of your estate. You can focus on LLM observability on specific clusters, namespaces, applications, whatever it is that you want to go feed into this. But something like I went out 6 hours and I see a whole lot more total LLM calls than I did in that 5-minute period. And if I open this up and I edit, I get a view of what my query interface looks like in order to go build these. because we're doing tracing at the eBPF layer, the fundamental units of a trace are spans. We categorize spans as a certain type. Span type OpenAI, span type Anthropic, etc. And that allows us to do simple things. This one is a very, very simple visualization. We're simply counting across all of these by span type. Juxtapose that with something that maybe has a little bit more complexity, average output tokens per second. This is a really important fundamental metric, I would say, for understanding model performance. There's been papers written on this, but the two, time to first token and output tokens per second, tend to be the ones that you find as being the most critical to understanding. Well, wonderful. Again, we have a metric that our eBPF sensor generates, ground cover Gen AI response usage output tokens. We also have another one, ground cover workload latency seconds. And using these, all I did was query this and average by Gen AI request model. And this one, I wanted to look for the 50th percent. That's what I wanted to look at. So the 50th quantile, if you will. And then I'm just dividing them. I'm doing A over B. That is a awesome formula that you can go build yourself to go find out what the average output tokens per second is by model. And that's what we have here. We only have one model being consumed in this demo environment. In the past, if I went back, I could show you, several different models being used. In fact, won't go back just yet, but you would actually see different groupings. This is the second one that we see most popularized by those in the space, telling us how we need to do analytics for LLM performance, average time to first token. So edit here. Again, we're just using a metric. In this case, we easily could have used a trace-derived filter as well. But we do generate this workload latency seconds. So I'm simply filtering to make sure that I'm interacting with the right systems. And again, I'm using the 50th quantile. And I'm grouping by Gen AI request model. So I get awesome, powerful visibility. All of our visualizations, you can build these in whatever way is meaningful for you. Time series gives us the ability to go build these in lines or even as stacked bars if we wanted to shift that, and easy updates. So anything that you need to do to go understand analytically, you can do. Another feature of ground cover is that there are very, very popular observability purpose-built analytics tools like Grafana out there. We have an embedded Grafana dashboard. So if there are questions that you want to ask and build visualizations on that we don't yet support, we're iterating at a very rapid clip in order to support and create complete feature parity, but you can certainly get to them this way. So again, I want to take you back to some of those fundamental components that I talked about, which are we want to give you access at the end of the day to all of the relevant metrics and interaction details that you may have. And this could be, if I just look here and I just say AI, I've got Gen AI metrics that are being generated by my sensor. In fact, I'll simplify it this way: response usage. I've got response usage total tokens, output tokens, input tokens, anything I want to go slice and dice. This could be as well as traces, and this could be looking for span type, where I can look and find these, and then I can find other specific features. We include these metrics inside of our traces as well. So I can go build the visualizations and ask the questions I need to ask to answer the questions that I have about things that are going on. So fundamentally, that is one of the most important features, is that we can get visibility into what's going on. The second is this lives inside of your own cloud. So this gives you the security of knowing that while we're able to help you, get visibility into every single transaction, you're not going to be penalized from the cost of ingesting them. And you're also not going to be penalized in terms of creating security vulnerabilities, because this data is still yours and it's still living with inside you and your environment. So you've got security there. And then we have other built-in features like that ability to go scrub PII or other features of that chat interaction that you may want to obfuscate from use, yet still provide the ability to go do analysis on. Holistic performance analysis, other insightful analysis about how people are interacting and using the chat experience, all at your fingertips. So LLM observability should not be thought of as a frightening, foreboding thing anymore. So that about sums up our demo. What I'd like to do next is answer any questions. Take just a quick second and see if there's any outstanding questions that folks may have out there from the field. So I do have a question. Looks like this is not necessarily an AI or LLM one, but somebody is asking that it says, so you mentioned that you do ingest open telemetry data. How does that work with eBPF? That's a great question. So this is a little outside LLMs, but yeah, if we go back to traces, this is the easiest way for me to showcase this. We have multiple different source types. We take in span data from OTel, eBPF, RUM. We can also take it in from various different others and create visualizations for this. So if I just say source open telemetry, what I find is that I've ingested these. Now, these could be coming in from lots of different systems. These could be workloads running in a Kubernetes cluster. These could additionally be workloads that are running not in a Kubernetes cluster, ostensibly, maybe Lambdas or on virtual machines or other serverless architectures. Really anywhere they could be running. This particular one I'll pick on, catalog service, and it happens to be running on a Kubernetes cluster in my demo environment. Now, because I came in through here, I'll go back really quick just to highlight something, is there is a difference between trace views, span views. We find span analytics to be more important. And so I'm coming in at the span layer, and this takes me to the span in question, but it puts it in context of the full trace. And these are all connected, these spans, by trace ID. But how I know this is running in Kubernetes is, I mean, there's a few different things other than it told me that it was running on a cluster, respected my filters, etc. But I also get this enriched by eBPF, because our eBPF sensor is able to go run on your Kubernetes cluster as a daemon set. You can actually send your OTel data directly through it. And we have a great better together story. We enrich the OTel data, so you still get full payload request and response. You get the header as well. If there are any span attributes, you get an additional field over here. You still get all your context picture, the ability to understand where this trace lives in timeline context of your system metrics, logs. Many organizations we find are on a journey to mature to either standardize on OTel log APIs and SDKs or embedding trace IDs into their logs, and maybe they're not there. So we can still correlate even without trace ID based correlation. It's pretty powerful. You get, of course, visibility from a flame chart perspective where the bottlenecks were. You get a full service map still with OTel, and of course you get a view holistically of the spans. You can build any analytics you want across this too, and any of the features you get in terms of creating views of sets of spans over timelines, anomaly detection or error detection insights, attribute drill down, all here. You can build these filters and create monitors, or even open in Data Explorer to go do additional analytics and build dashboards from. So wonderful question. Love to answer that all the time. And I apologize. I would love to answer more questions, but it looks like we're running out of time. So with that, I do want to close and say thank you very much. I appreciate you spending all this time with me. I'm sorry we ran out of time. If there are additional questions, please let us know and we'll follow up individually with you. Hopefully this gives you a much better understanding of how Bring Your Own Cloud can unlock you, give you freedom from SaaS, as well as give you all the value that you need as we enter into this AI era. Again, Adam Hicks with Groundcover. I look forward to talking to you again, and have a wonderful day.